Hello my dear students, welcome back to the class. Let's have a look at what we are going to learn in this session. In this session, we are going to learn Basic Proportionality Theorem, in short we can say BPT. It is also popularly known as Thales theorem and its applications. Okay, so in this session, in depth we are going to discuss about Basic Proportionality Theorem and its proof as well as and its applications, right? Are you ready? Let's begin. Theorem. State and prove basic proportionality theorem, in short BPT, or we can also say Thales theorem. So whose statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So according to basic proportionality theorem, the statement saying that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Clear? Let's visualize this statement as a figure. So here, if a line is drawn parallel to one side of a triangle, here ABC is a triangle. If a line is drawn parallel to one side of a triangle, here you can see DE is parallel to BC. Okay. To intersect the other two sides in distinct points, here you can see DE intersecting other two sides in distinct points. One is at D and other one is at E. Okay. Then the other two sides are divided in the same ratio. So we need to prove other two sides are divided in the same ratio, that is AD over DB is equal to AE over EC. This is what we need to prove. Clear? So let's prove. Given in triangle ABC in which a line DE parallel to BC, okay, it is given in ABC triangle DE parallel to BC intersects AB at D. So this DE line intersecting AB at D and AC at E, this line intersecting AC at E. Okay, so that is DE parallel to BC. So in short we can say this line is parallel to this line. So here we need to prove this over this is equal to this over this. Okay, to prove AD over DB is equal to AE over EC. For proving this we need little modifications in the diagram. So let's construct here join BE and CD. Here we joined BE and CD as well as, and we drew EF perpendicular to AB. Here you can see EF perpendicular to AB and as well as DZ perpendicular to AC. Here DZ perpendicular to AC. So these are the modifications we have done in this diagram to prove this. Okay, so let's prove. Proof. So area of triangle ADE, here you see triangle ADE. In this triangle, to find this area, that is half into AD into EF. How we got this? This is based on area of triangle formula, that is half into base into height. Okay. In this triangle, you can see AD is the base and EF is the height. Okay. So half into base into height, that is half into AD into EF. So here we are given equation number 1 for this statement. Okay. And area of triangle BDE. So look at this figure BDE. Now we are finding area of this triangle. Okay. So in this triangle this is base and again this is height. Again by using area of triangle formula, that is half into base into height, half into BD into height is EF only, right? This is perpendicular, right? So half into DB into EF. Here we are given equation number 2 for this statement. Now dividing equation 1 and 2. Now we are dividing these two equations. Okay. So we are dividing both left hand side parts as well as right hand side parts. Area of triangle ADE over area of triangle BDE is equal to half into AD into EF over half into DB into EF. Here half gets cancelled, EF gets cancelled, then we get AD over DB. So let's take this is equation number 3. Clear? Now similarly, area of triangle ADE over area of triangle DEC. Look at here, ADE and DEC, these two triangles areas. So for this triangle, area is half into base into height, that is here base is AE, height is DZ, right? Half into AE into DZ. And for this triangle, again half into base into height. Base is EC and height is again DZ, so half into EC into DZ. Again half gets cancelled, DZ gets cancelled, then we got AE over EC. So let us take this is equation number 4. Next, since triangle BDE and triangle DEC stand on the same base DE, you can see triangle BDE and DEC. These two triangles having the same base, what is that? DE. Okay. And between same parallel lines, that is DE and BC. You can see this triangle and this triangle. For these two triangles, they are having same base DE, as well as both triangle lies between same parallel lines. What are they? BC and DE, right? And we know that when two triangles having same base and lying between same parallel lines, their areas are equal, right? So we can say area of triangle BDE is equal to area of triangle DAC. So let's give equation number 5. Now from equation 3, 4 and 5, what we can conclude? From equations 3, 4 and 5, AD over DB is equal to AE over EC. Because from equation 3, we have got area of triangle BDE over area of triangle DEC is equal to AD over DB, right? From equation 4, we have got area of triangle ADE over area of triangle DEC is equal to AE over EC, right? Since these two areas are equal, so denominators are equal, then left side both parts are same, so right side both parts are same. So from equation 3, 4 and 5, we can say AD over DB is equal to AE over EC. Clear? So this is what we need to prove. So hence it is proved. Clear? There are some following results based on BPT. So let's have a look at them. Corollary. We have proved that AD over DB is equal to AE over EC, right? This is what we have proved so far. So adding 1 to both sides we get, so adding 1 to both sides of this equation, AD over DB plus 1 is equal to AE over EC plus 1. So on adding, taking LCM, here we get AD plus DB over DB, on the right side AE plus EC over EC, right? And again we know AD plus DB is equal to AB, right? And AE plus EC together, that is AC. So this we can rewrite AB over DB is equal to AC over EC. Or we can say that on reciprocalizing both the sides, so DB over AB is equal to EC over AC. So these are the following results. Not only AD over DB is equal to AE over EC, we can also say AB over DB is equal to AC over EC. Also we can say DB over AB is equal to EC over AC, right? Similarly, AD over AB is equal to AE over EC, again reciprocalizing, AB over AD is equal to AC over AE. So these are the following results. So whenever we come across and whenever we need such situation, we can directly use them. Clear? So this is about basic proportionality theorem and their corollaries. Clear? Hope you understood. Shall we discuss once again briefly? Yes? Okay. So here the statement of basic proportionality theorem saying that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Okay. Here we are given triangle ABC in which a line DE parallel to BC intersects AB at D and AC at E, that is DE parallel to BC. And we need to prove AD over DB is equal to AE over EC. This over this equal to this over this. So for that we have done little modifications in the diagram, that is construction. So we have joined BE and CD. Here we have joined BE and CD, as well as we drew DZ perpendicular to AC and EF perpendicular to AB, right? So now considering this triangle, area of this triangle, half into base into height, so half into AD into EF. So we have given equation number 1. Similarly, in this triangle area, half into base into height, half into base is BD and height is EF. So on dividing these two equations, we have got AD over DB, right? Next, similarly, area of triangle ADE over area of triangle DEC, that is this triangle area over this triangle area. So from this we have got AE over EC, this relation. Again you can see this triangle and this triangle, these two triangles having same base DE and they are between same parallel lines, so their areas are equal. So this area is equal to this area, so we have got this area equal to this area, right? So we have given equation number 5. Now combining equation 3, 4 and 5, we have got AD over DB is equal to AE over EC. We have proved basic proportionality theorem here. So there are following results. So what are they? These we can call as corollaries. Here are the corollary. What is that? This is whatever we proved and we have added both sides with 1. And further we simplified, we have got some more results. What are they? AB over DB is equal to AC over EC. On reciprocalizing, DB over AB equal to EC over AC. Similarly, we have also got AD over AB is equal to AE over EC. On reciprocalizing, AB over AD equal to AC over AE. This is about basic proportionality theorem and its proof. Clear? And here are some important theorems. Anyhow, we are not going to prove them, so we will use those statements directly whenever we require. So let's have a look at them. What are they? First one, midpoint theorem. So it is saying that the line segment joining the midpoint of any two sides of a triangle is parallel to the third side and equal to half of it. So midpoint theorem saying that the line segment joining the midpoint of any two sides of a triangle is parallel to the third side and equal to half of it. Hope you will remember, right? Next one, angle bisector theorem. It is saying that the internal bisector of an angle of a triangle divides the opposite side in two segments that are proportional to the other two sides of the triangle. So let's look at once again. The internal bisector of an angle of a triangle divides the opposite side in two segments that are proportional to the other two sides of the triangle. These are the two theorems we will use whenever we require to prove other statements along with basic proportionality theorem. Clear? This is it.